All right, in goal 9.2, you will need to pay extra close attention. I don't know how much of this you have seen or been exposed to before, but it can be confusing. So please pay attention and get good notes down. Okay? First of all, just a couple of reviews of graphing in terms of open and closed circles and going in the right direction. Okay? X is greater than 3 would be an open circle going to the right. Greater than or equal to -1 would be a closed circle going to the right. Less than -2, open circle to the left. Less than or equal to 0, closed circle to the left. So let's make sure we can distinguish between open and closed circles. That when I have a less than or greater than, that's when my circle is open. When I have greater than or equal to, less than or equal to, that's when my circle is closed in. And then the direction of your inequality symbol is the same as the direction of the line if X is on the left side. So this is pointing to the right, which means my line is going to go to the right. These are pointing to the left, which means my line is going to go to the left if X is on the left side. So you can use that fact only if X is on the left side of the inequality. And I try to solve it, that happens all the time. So I typically bring my X to the left, so that should be an easy task for us to do because that's what we've been doing. Okay, so we're going to start with a conjunction. A conjunction is two statements joined by the word and. To be true, both statements must be true. The solution set is the intersection. So the blue words are the important words here to know and correlate with each other. And is an intersection. So what do I mean by intersection? I mean what's common about them, what's the same about them. We're going to be doing some graphing so I can look at where the graphs overlap each other. Okay, so an and is an intersection, and then what I have in parentheses there describes what an intersection means. Okay, the solving is the easy part. Okay, because this is even easier than the assessment you took today. But it's the putting it together for my answer that's different. Okay, so I have two separate inequalities that I will solve. So I'll subtract 1. So X is greater than -6. And on the other one I'll divide by 4. X is less than or equal to 3. You have two answers, two parts to your answer, I should say. First is a graph. So when I draw my number line, I'm not picky about all the little marks between the two numbers that I need. I just need -6 and 3 on there. Please know that -6 on a number line is to the left of +3. Okay, if you don't know that much, nothing's going to come out right. Okay, I don't need all the little hash marks between and all that stuff. So I'm going to graph first. I'm going to start by graphing what I refer to. So this is not mathematically any book anywhere, okay? But I refer to them as my helper graphs. And my helper graphs are the graphs of the two individual inequalities that you just solved. So X is greater than 6 would look like that. Open circle to the right. Less than or equal to 3 would be a closed circle to the left. Those are the graphs of the individual inequalities that I just solved. They are not my answer. They're simply going to help me get my answer. They don't have to be there. Once you see how I do these, if you don't need helper graphs, then don't do them. It's going to be up to you. I'll leave it completely up to you. I'm going to keep doing them because obviously I think they're helpful. That's why I call them helper graphs. Okay? I think they can help you get your solution. Now, what we're looking for is the intersection. So meaning that we're looking for numbers that work here and here. We want the numbers that work in both of these. So for example, in this one here, the number 15 would work. 15 is greater than negative 6. That's true. 15 is not less than or equal to 3. So 15 works here, but does not work here. In this one here, the number negative 25. Negative 25 is less than or equal to 3? Sure it is. Negative 25 is greater than 6? No, it's not. So we have numbers that work here, but not here. We're looking for the numbers that work in both of them. Okay, when you have an and. So 0. 0 is greater than negative 6. That works. 0 is less than or equal to 3. That works. So that's what you're looking for when you solve an and. The numbers that work in both. So with our helper graphs, we can see where that's happening. If I start here at this circle, and I go to the left, that only works in the top line. Those numbers all the way down are only going to work in the top. If I start here and go to the right, they're only going to work on this bottom line. But right here, this is where my graphs are overlapping each other, which means that's the numbers that work on both of them. So my final answer graph looks like this. The numbers between, my stylus is not working well today, negative 6 and 3. And notice that I just repeated the kind of circle it was. This was a negative or an open circle, so that's an open circle. This is a closed circle, that's a closed circle. And all of those numbers work for both. I am going to refer to this, again, not mathematical at all, as a dumbbell graph. You know those little hand weights that you hold and you lift for your biceps. Okay, so the circles on the outside, open or closed with the line between it. I'm going to call that a dumbbell. You know what kind of weight I'm talking about? You with me on that? Okay, so a dumbbell graph. That's my graph answer. To get your algebra answer, this is going to be probably the hardest part of the whole process. And every question I do today, this is the thing I think I will see the most trouble with. You take your negative 6 and your 3 and write them on the outsides with an X in the middle. And then you write your symbols to the left. Oops, that one didn't go because I held it down. And then because the 3 is closed in, I also need that equal to part. This is my algebra answer. That's the answer I will expect for your algebra answer. So what I want you to see is that what I did was I took these two inequalities and combined them into one. Okay? So you can see that it looks the same. So x is less than or equal to 3. That's exactly what that looks like. And if I come up here, it looks backwards, but it's not, because look at my inequality over here. Where's that pointing? It's pointing at the negative 6. And if I look here, it's still pointing at the negative 6. So what I'm doing is I'm combining these inequalities into one. And I'm going to refer to this as a dumbbell answer. So a dumbbell answer is one in which you have an X in the middle, two numbers on the outsides. Okay? So that terminology, while it's not, you know, anywhere in a math book, it's going to be important, I think, to help you do these. Okay? So again, the pink graphs are helper graphs. They are not my answer. I don't even care if they're there or not, although I do think they're helpful. The graph that you put on the number line is the graph I will grade. That's the one I'm going to look at. And then my algebra answer matches my graph. Okay, some questions. I'm not finished. We're going to do more of these. You know, I'm like, okay, done, okay, no. Okay, I know if you've never done this before, it takes a little bit to sink in. Will.
So for the quiz that we're having, are we gonna need to put the number line?
I'll draw one on. I'll have one drawn on there. Yep.
So how did that arrow end up switching?
It didn't switch.
It didn't?
No, because look, it still points at -6. It's still
Oh,
pointing
okay.
at -6. I just wrote here X is on the left, here my X is on the right.
Oh, alright.
So I didn't actually switch it. It looks like I did, but I didn't. Okay, so let's do another one. I won't have as much to say on this one because it's going to be repetitive of this. The solving should be simple. That should not be an issue at all. Add 3. X is greater than or equal to -8. Add 3. X is less than or equal to -5. Please, when you draw your number line, know that -8 is smaller than -5. Because if you don't, this won't work. So my helper graphs, which are optional. X is greater than or equal to a -8. X is less than or equal to a -5. And we're looking for, because it's an and, we're looking for the intersection. And is an intersection. What numbers are common? Where do the graphs overlap? And that's right here between -8 and 5. -5. -8 and -5. So they're overlapping here. Circles are closed just like the helper graphs. And I meant to put that in a different color. So give me a second to put that in orange. And then when I write my algebra answer, smaller number, larger number, X in the middle, and then they point to the left. And because they're closed circles, they are have the equal to part also. That's my algebra answer. And again, I refer to this as a dumbbell graph, and I refer to this as a dumbbell answer. Dumbbell answer meaning X in the middle, numbers on the outside with 2 symbols. Okay, question. I'm going to change it up. You'll notice that this next example, I'm going to shrink it just a little bit here, does not say the word and in it. But what I want you to know, because of the way it's written, numbers on the outsides, X in the middle, that this is an automatic dumbbell.